Welcome to Study Loop.
Let's use the substitution to rewrite this integral as a rational function. So here, let's go ahead and take u to be this term in the denominator. So u would be the cube root x squared plus 1. Then we could go ahead and differentiate right now, but let's make this easier by cubing both sides. Get rid of that radical. Then go ahead and take a derivative on each side. Differential. So we see that there's a dx in the original problem, so let's go ahead and solve this new expression for dx. So we'll divide both sides by 2x. And then we can say what x is by using this equation here. So x squared, u cubed minus 1. Then here, if we want to use x, let's just take the square root. So we have 3u squared, u cubed minus 1, 1/2 power. We also have a 2 down there, and then du. So that's what we'll use to replace the dx. Now we also have to deal with x cubed and the denominator. So let's look at x cubed. We can get that by just cubing both sides of this equation. So then we have u cubed minus 1. Then raising this to the 3, we have 3 over 2 is our power. So the integral x cubed is u cubed minus 1, 3/2. And then for the denominator, we see that we just have this term here. And by our u subs, this is just u. So we can just put a u down here. And then we found dx to be this expression over here on the right. 3u squared, 2 u cubed minus 1 to the 1/2 power. And then du. Now we'll just go ahead and simplify. The way that it's written, it's technically not a rational function until we cancel because of these 1/2 powers. These are not polynomials. So let's go ahead and cross off. So we have a 3/2. Let's subtract that 1/2 power. We'll just get an exponent of 1. Now we'll have a rational function. And further, let's take off one of those u's. So we just have integral. Let's pull out the 3/2. And then left over, we have a u. And then u cubed minus 1. And the denominator is no longer there because it canceled. So this we can go ahead and simplify. U to the 4th minus u. And then let's go ahead and just use the power rule twice. 3/2 u to the 5 over 5 minus 3/2 u squared over 2. And now we add our constant of integration c. And the last thing to do here is to just replace u with x. So this is where we use the original definition of u. So we have 3 over 10. And now u to the 5th will become x squared plus 1. So originally it was to the 1/3, but we're raising that to the 5th. So we get 5/3. And then here, 3 over 4, x squared plus 1. This time we're squaring it, so it's to the 2/3. Then we add our constant of integration c. And that's our final answer.